In this video, we're going to continue with properties, but this time focus on the chemical properties. So again, there's two types of properties that you can use to describe substances. We have physical properties and chemical properties. Physical properties can be observed without changing what the substance is, whereas chemical properties, when you want to observe them, you need to change a substance in some way. You change its identity, for example. And so we'll take a look at the various examples of chemical properties that exist. The main examples that we're going to discuss are combustibility and flammability, as well as reactivity with. So, as I mentioned, chemical properties can only be observed when you're doing a chemical change of some sort, when you're changing the identity of what your substance is. So they're not as easy to observe as physical properties. Physical properties, again, can be something as simple as that piece of paper is yellow. The carrot is orange. The ring is lustrous. Those are very easy to observe. You don't have to change anything about the substance. When it comes to chemical properties, you do need to change the substance to find out that it has that chemical property. One example of a chemical property is combustibility. It just means your ability to burn. So paper catches fire, it's combustible. You might sometimes see reacts with blank. So we can fill that there with reacts with acid. So if I take a piece of metal and I put it in, or if I take some baking soda and I put it in some vinegar, the baking soda reacts with the vinegar. Vinegar is an acid. So baking soda reacts with acid. That's a chemical property of the baking soda. Or some things might react with water. So I might take a piece of, let's say, sodium metal, put it in water, it starts to react. So that's the chemical property of the sodium. The sodium reacts with water. When it's reacting with the water, the sodium and the water, they're forming new substances, which is why it's a chemical property as opposed to a physical property. And then I can also take a look at sensitivity with light or reactivity with light. So there's some substances, when you put them in the light, they start to decompose. So it's sensitive to light or reacts with light. And that's another example of a chemical property. There are others out there, and this is a bit simplified, but at the level that we're studying right now, that's really all you need to know. And for actually a lot of just the main chemistry labs that you'll be seeing, it's really at this level that you need to understand chemical properties. You might also learn about pH, which is a measure of acidity. That also counts as a chemical property, but we'll take a look at that in more detail when we get to our units on acids and bases. So combustibility essentially just means the ability to burn something. So if we look over here, we have a barbecue, and there's a barbecue tank over here, and that's filled with a gas called propane. And so propane is combustible, which means that when you expose it to oxygen, it'll burn. It'll form carbon dioxide and water and then release a whole bunch of energy in the form of heat and perhaps some light, but mostly heat, so we can cook the food that we're putting on the barbecue there. So the propane is considered combustible. And again, that's just the ability to react with oxygen. So burning is really just reacting with oxygen. Another less extreme example of burning is actually rusting. So iron is combustible. So all this rust you see here is actually iron reacting with the oxygen in the atmosphere to form an iron oxide compound. And so that's an example of combustibility as well. The iron is a combustible metal. It reacts with oxygen in the atmosphere, and that's rusting. So you can think of rusting almost like slow burning. Here we can see a few more examples. So this is a magnesium ribbon, which is a metal. We put it in some hydrochloric acid. So this is a solution of hydrochloric acid over here. And you can see it starts to fizz and bubble and all that. So we see a reaction happening. But the point is that this magnesium ribbon reacts with acids. That's a chemical property. And when it's doing this, we have new substances forming, which again means that we have to change our substance to identify this property. So the new substances forming, you'll learn later on, or you might remember from grade 10, would be some gas, some hydrogen gas actually. And then in here, there's also some magnesium chloride that's dissolved in there that has formed as well. Here we can see an example of sodium reacting with water. So we put the sodium metal into the water, and you can see all that light being released, all that energy being released. But the point is that sodium metal reacts with water, which is one of its chemical properties. We had to change the substance to identify this chemical property. So when this reaction happens, you may remember from grade 10, um, there's a new substance produced. There's some NaOH and also some hydrogen gas that are produced during this process. And here we have an example of something that is sensitive to or reacts with light. So silver nitrate, if you use that in grade 10 for some labs, you would have noticed that your teacher brought it out in a container that was dark. And the reason for that is because when it's exposed to light, when silver nitrate is exposed to light, we say it's photosensitive. It will break down quite quickly. And so we're losing a lot of our silver nitrate. Silver nitrate is actually used in dark rooms if you're developing photos. For example, if you've ever done that or you've seen it in TV shows or in movies. So this is just another example of a chemical property of a substance.